Good evening, friends. Today we will talk about scalars and vectors. We know that all physical quantities can be divided into two groups. One group is called scalar quantity, another group is called the vector quantity. So, what is scalar quantity and what is the vector quantity and what is the mathematical operation that we will talk about now. The first of all that we will talk about the scalar quantity. Okay, so what is the scalar quantity? Scalar quantity or simple scalar, they have only magnitude, or we can tell it size. So it has only magnitude. Okay, and it is can be completely specified if their magnitudes are given. So it doesn't have any direction. Clear? So scalar quantities have only magnitude and can be completely specified if their magnitudes are given. So these quantities obey the rules of ordinary algebra rule, right? Ordinary algebra rule they follow. Ordinary algebra rule means 2 plus 3 is equal to 5. For example, the mass of a body 1, its mass is 2 kg, and the mass of body 2, its weight is 3 kg. So the total mass that is 5 kg. Okay, so ordinary algebra process is applied in scalar quantity. Means ordinary algebra means addition, there is an add, subtract, multiplication and division method, normal division method. These four we can easily apply it. For what? For scalar quantity, right? So now you can ask me what is the example of the scalar quantity. Here I am giving you some example, that is mass, that is length, that is time, that is volume, that is speed, that is density, that is electric current. Why electric current? That I will discuss when we will study then electricity. Then, okay, then electric potential. Right? Then gravitational potential. Gravitational potential. So these all are the very, very important. Then kinetic energy. Okay, then is the magnetic potential energy, etc. So these all will come under scalar quantity. Now, this is a very important thing that you should know. Suppose, why, if I talk about the mass of the water bottle, then we can say it is a 2 kg. But we don't say it is a 2 kg towards north. We don't say it. Right? What is the length of the field? The length of the field only the 4 meter. We don't say the length of the field is a 4 meter towards northeast. We don't say it. So this is why this all will come under scalar quantity, because scalar quantity has magnitude only and it doesn't have any direction. Clear? So this is called the scalar quantity. Now we talk about vector quantity. What is this vector quantity? Vector quantity, or simply that is in vectors, it has both magnitude and direction. It has both and can be completely specified only if both magnitude and direction are given. So these quantities do not obey the rules of algebra. Okay, so what they always, they doesn't obey the rules of algebra, they obey the triangle law. They obey only triangle law, which will be explained. I will that which will be explained later on. I will do that. Some examples of vector quantity, that is, scalar quantity is speed and vector quantity is velocity, displacement, okay, force, intensity of electric field, intensity of electric field, okay. If intensity of magnetic field will also come under the vector quantity, then gravitational field will also come. Then gravitational field also come. So that is a very important, these all are the examples. So as mentioned, a vector has a both magnitude and direction. Suppose we are making the velocity, suppose, of a body. The velocity of a body is, suppose, 10 meter per second, or we can write 10 meter per second. So it says in a particular direction towards east. Then it is velocity. Otherwise, if I write only this, then it is speed. Okay. So this velocity can be represented by a line segment of a particular length with an arrow at one end. Okay, the arrowhead points to the direction of the vector. The length of the line segment gives it the magnitude. Okay, suppose this is 10 meter per second. So the length of the line is 10 meter per second. It is in magnitude, and this arrow sign, it indicates its direction. I hope it is very clear. Right? Suppose a body is moving with a 4 kilometer per hour towards y axis. How will I graphically represent it? So the graphical representation would be this one. Alright? It is in 4 kilometer per hour. So the length of the arrow, so this length is its magnitude, and this arrow sign indicates its direction. So in case of suppose A, it is a vector. How will I identify it? So write a arrow sign on its head. So this arrow symbol on it the letter that indicates that the letter represent a vector quantity, right? I hope up to this it is very clear to you. Hope it is very clear. Now, what I told you before that, uh, vector does not follow the basic algebra or normal algebra rules. It follows the triangle law. So we will just talk about it in a proper ways. Suppose there is a man. Suppose it is a river. Okay. Right. So this is in water that is on flow suppose towards these directions. All right. It is fall through it 3 km per hour. These directions, right? And a man is standing over here and he is going towards this direction. He wants to go towards this direction with a 4 km per hour, right? So the river flows towards an x-axis and the man is trying to move to the y-axis. All right, right? So how it is possible? How it is possible? Suppose if I draw uh, if I draw one line over here, then it will be helpful. Just want to give a line over here, and this is the line x-axis. Okay. Now this is the y-axis. This is x-axis. We can imagine that. Here it is a 4 km per hour, and it is a 3 km per hour. River flows directions. All right. That's important. So long as the man swims, he is also being carried away if he tries to swing towards y-axis directions, but river flows towards these directions. So river also apply a force to the man, and so the man carries away or carried away by the river current along the x-axis. So the man has the simultaneously two velocities. One is 3 km per hour along the direction of a river flow, and another 4 km per hour perpendicular to it. So in 1 hour, the river will carry away the man along the x-axis by a distance of 3 km, and the man himself will cover a distance of 4 km by swimming along the y-axis. So at the end of the 1 hour, the man will neither be at the suppose it is a uh, suppose 3 km 1 hour, so neither be at a point of A, okay, nor at a point of B. So here we can draw one perpendicular to it. So he will be near about the point at the C. Clear? So we can draw one diagonal of this square. Okay. Now it is a starting point, that is an O. So here we can write OC square is equals to root over OC, uh, we can write OC is equal to root over OA whole square plus OB whole square. So it becomes 3 square plus 4 square. It means that is a root over 25, means it's a 5 kilometer. So after 1 hour, it will be at a position of the C, that is a distance from origin, that is a 5 kilometer. And here it makes an angle. Suppose this angle is theta. So what is the value of this angle? So tan theta should be perpendicular by base. So if it is a 4, then it is also the 4 kilometer per hour. So it becomes 4 upon 3. It is clear? So if the first portion, that is an OA on the x-axis, if it is the first vector, if OB on the y-axis it is the second vector, then OC is also a vector. So this OC, this vector is called resultant vector. Is called resultant vector. And you need to understand it in a very proper way. I hope up to this it is a very clear. And what theory that we have applied over here, that is called the triangle law of vector addition. This is called the triangle law of vector addition. I hope it is clear to everyone. Thank you very much. Have a nice day.